Name the rigid motion that maps figure S onto figure S prime. Remember the three rigid motions that you know so far, or that you can choose from, are rotation, reflection, and translation. You can use this as like a word bank to help you answer questions 1 through 3. You are identifying which rigid motion moves S to S prime. Here we have 3 pictures that look somewhat similar, and then one that does not. Which one does not belong? A is a translation. C would be a reflection. D could be a reflection or a rotation. But B, the two shapes are not the same size. That one requires what's called a dilation, and a dilation is not considered rigid motion. So A, C, and D all use rigid motion. However, B uses a dilation, which is a non-rigid motion. Here we see these are dilations. There's different sizes of the same shape triangle, different sizes of the same circle, and different sizes of this polygon. However, these are not dilations because they are all the same size. These ones are just rigid motions. So B does not belong. Here's a little bit more of a description for those two different types of things. A transformation is a rule that maps each point of the plane to a unique point in the plane. Transformations would be all of those rigid motions. A rigid motion is the result of any movement of the plane in which the distance between any 2 points stays the same. So transformation is more of a general term. It includes our rigid motions as well as a dilation. The way that a dilation works on a grid or on a plane is through a point. You dilate from a point. So we have this point O and this triangle ABC, and they're going to dilate from that point O. In order to do this, you need to draw a line from the point of dilation through the vertex on the shape. So the line's going through each of the points in the shape. You can do more than those, just the vertex, but those are the minimum requirement. Then, if we were dilating by a scale factor of 2, this distance between O and A is doubled to go to O to A prime. The distance from O to B is doubled to get to B prime because we have that scale factor of 2. If we wanted a scale factor of 3, we would triple that distance. If we wanted a scale factor that was smaller than 1, like a half, for example, we would take that distance between O and B and split it in half to find the location of B prime. We can also move this point of dilation, and it's going to change the resulting location of our image. So here we have a dilation and a scale drawing. You can see that the size of the scale drawing changes just like the size of the dilation changes. The main difference between these is that with a dilation, you're moving from a specific point, whereas with a scale factor or a scale drawing, this can be anywhere in the plane. I want you to go through this set of transformation cards and identify whether they are dilations or not dilations. If the scale factor is 1, it keeps something the same size. So in T2 and T3, those could be considered dilations because they would use a scale factor of 1. But traditionally, we would just say that it's rigid motion. It doesn't require a dilation to get from here to here. So this one would be a dilation. The size changed. This one requires a dilation. This one and this one. These are not the same shape, so they are not dilations or rigid motions. These ones are all the same size and the same shape, so those ones are only rigid motions and do not require a dilation. There are two different types of dilations. One is called a reduction, and the other is called an enlargement. If the gray is the original, is this dashed triangle a reduction or an enlargement? It is an enlargement because it is larger than the original. If the dashed line is smaller than the gray original triangle, we would consider that a reduction. In your workbook, I would like you to list out, for example, oh, this is the wrong side. List out the cards you see here, and then next to each one, write whether it is a reduction or an enlargement. Go through all 7 cards, listing whether they are reductions or enlargements next to each one on your workbook paper. Once you have finished that, I would like you to also accomplish the 2 problems on the exit ticket, and then you can staple those together to submit them. And that's it for lesson 1 of module 3 on dilations and transformations.